Okay, probability 4. Let's look at mutually exclusive events and non-mutually exclusive events. So take the heading down and pause the video. Okay, mutually exclusive. So in probability, we get asked these questions where the words that are in the question may make it look confusing, but the math involved is actually pretty straightforward. If we go back to the cards, and actually we'll look at sets here. Let's look at set A and set B. A and B. If set A is the set of black cards, and set B is the set of red cards, we can see that A is in here, there's 26 in there, and B in here, there's 26 in there. So in the intersection, there is nothing. So we can say that these events are mutually exclusive. Now we should probably use squiggly brackets when we're drawing out sets. So we go back to the cards again and we look at non-mutually exclusive events or not mutually exclusive. Let's do two sets again. Set A and B. Okay, do you remember the jack question and the spade question from the previous video? So the probability of jack, let's just say, or let's call set A jacks. A is equal to the jacks, and B is equal to the spades. I'm being a bit lazy here with the non-squiggly brackets, but bear with me. So B, in A we have the jacks, so we have four things in A. But one of them is a jack of spades, which leaves 3 in here. And how many spades altogether? 13, which leaves 12 in here. So you can see that we have 16. We said the probability of jack and spades from previous, the probability of a jack or a spade was, you remember, 16 over 52? So you can see here, 3 and 1 is 4 and 12 is 16. So we may be asked to prove that something or two events are not mutually exclusive. So the way to set it up is that the probability of A union B is equal to the probability of A plus the probability of B. Now the probability of A in this case, I'm just going to do a minus here. The probability of A we can see is 4. Probability of B is 12. Now what would we have to get rid of? We'd have to get rid of the probability of A intersection B. Minus 1 equals 15 over 52. So I hope you're all shouting my mistake at me. The probability of B is 13. And again, mistakes are gold in maths. You identify your mistake, don't make it again. So we have both 16 over 52. Taking this into mutually exclusive, the probability of A union B, set theory, is equal to probability of A plus the probability of B, which we saw earlier with the 26 plus 26 being 52. So many of the questions in probability are based around dice. So let's do a set of 2 dice being rolled. Let's see what we have here. So I want a 1, a 2. These are the outcomes, 1 to 6, and down the left hand side. Oh, getting rid of all the lines for me. Okay, we won't worry about the squiggles at the bottom. 1, 2, 3, 4, 5, 6. Okay, let's look at the total of each roll. And it's good to actually do this, practice it a few times, and you'll actually remember what the answers are to a lot of these questions. So the potential outcomes here, the lowest you can get is obviously a 2. 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and 7, 8, 9, 10, 11, and the greatest possibility is 2 6s, which is a 12. So the probability of getting a 2. How many 2s are on the board? 1 over 36. Now there's a pattern here, so when you practice this a couple of times, you'll remember the pattern. The probability of getting a 3 is equal to, look at the board, there are 2 of them. Can you see the pattern so far? The connection between 1 and 2, the connection between 2 and 3. So you're going to tell me, I'm going to shout out loud the probability of a 4, 3 over 36. The probability of a 5, 4 over 36. Let's just double check our diagram. 1, 2, 3, 4. The probability of a 6 is 5 over 36. Is this just going to keep going? Let's have a look. The probability of a 7 is 6 over 36. Now, a bit like Pascal's triangle, which we saw earlier, we now go backwards. So once you get past 7, what do the numbers add up to? The probability of an 8 is 5 over 36. Now, 13 is my favorite number. 5 and 8 is 13. The probability of a 9, 9 and 4 is 13. So remember the number 13 for this pattern, going down this way, and this one, what I will call 1 less, going down that way. So if you can remember these little patterns of maths, it makes maths a lot easier. The probability of a 10, 10 and 3 is 13. The probability of an 11, 11 and 2 is 13, and the probability of a 12, you've all told me, is just that one little guy there, which is 1 over 36. Okay, so take this down in your copies, pause the video, and then we'll look at the answer. Conditional probability. This is what conditional probability looks like. The probability of female, this straight line, we read as given the person wears glasses. That's a G. So there's 15 males in the class and 5 wears glasses. There's 10 females and 3 wear glasses. A student is picked at random from the class. What is the probability that the student is female, given that the student wears glasses? So that's this question here. The probability that the female, given they wear glasses. So we're going to let M equal the males, F equal the females, and G equal the glasses. So this is a formula. So F given G is equal to probability of F intersection G over the probability of the second thing happening, the probability of G. So what's the probability of F intersection G? Well, let's have a look back up here. 8 wear glasses. So it's like 2 individual probabilities. So 3 over 8 is the probability of F intersection G. So F intersection G, this is a 3. That's the number we're looking for out of this set. And the probability of glasses is an 8 here. So the answer to this one is 3 over 8 because they've already worn glasses. And 3 is the amount of females. Okay, so take this conditional probability question into your copy. Find the probability of X given Y. Then we look at the probability of Y given X. So the formula again, remember what it was? The probability of X intersection Y over the probability of the second, which is Y, which is equal to 0.2, the intersection, and Y is 0.3, which is equal to 2 over 3. What about the probability of Y given X? It's equal to the probability of Y intersection X, which is the same as X intersection Y, over the probability of the second, which is X. So again, on top we're going to have 0.2, and on the bottom we're going to have 0.3 and 0.2, which is 0.5, which is 2 over 5. Straightforward enough probability questions. which is equal to 2/3. Okay, so take this question into your copies. Probably a little bit trickier than the other two. So 60% in the USA are Republican, 70% of them support gun ownership, 40% are Democrat, and 10% of them support gun ownership. So we're told that a voter is selected at random and they announce that they support gun ownership. What is the probability that they are Democrat? So we're looking for the probability of Democrat given gun ownership. So there's a couple of things we need to look at here. Let's let Republican equal R, Democrat equal D, and gun ownership equal GO. Let's write down our probabilities. The probability of R is 60, 0.6. The probability of Democrat is 40, which is 0.4. And then we need to find out how many support gun ownership. Okay, gun ownership. Let's have a look at this. 70% of 60%, so 0.7 by 0.6. 7 sixes are 0.42. Then we have 10% of 40%, which is equal to 0.04. So 0.46 of total percentage is gun ownership. So we're asked to find the probability of D given gun ownership. Now, given gun ownership, that 46 we can see is the given gun ownership. So the probability of Democrat given gun ownership is this guy. 4% of the Democrats, or 4% of the total. So the probability of D intersection gun ownership divided by the probability of gun ownership is equal to 0.04 divided by 0.46, which looks to be 2, if you divide both of them by 2, multiply by 10, 2 over 23. Now, go to your books, practice some of these questions, and hopefully you understand probability.